You know what is one of the most difficult part in GenAI application development? Complex PDF parsing, and many people face same issues where that we have PDF that has snapshot like data in a snapshot and images and complex structure. It is very difficult to parse that PDF and get those information so that we can utilize into LLM to get the useful information. What is that basically? So we have retrieval augmented generation in GenAI application development because LLM doesn't have private information like closed source information, and if we want to get sense of that information using LLM, we need to provide as a context to LLM. Now we have complex PDF that has a lot of information that is stored as a embedded maybe snapshot, data in snapshot, complex layout where things are not easy to extract because it is not a simple text. That time if we want to use that PDF and store that information after embedding those information in a vector store, vector databases, it is very difficult because you may lose context because it is scattered. If you do with like simple PDF parsing, it is very difficult to get those information in like coherent way so that we can get sense of that one. Even vector database get sense of that one if you want to store this one. Now if you want to retrieve information from the vector database and use LLM to get the certain output, get that certain useful information, it's difficult because information at the first step itself failed as a like a parsing, proper parsing. And that's what many people are facing same issues when we go with production GitHub application where data is complex and available as a PDF. So we will see what are the tools we can like PDF parsing techniques like libraries or tools we can use it so that you can take better and wiser decision based on the complexity of PDF. Some tools are very specific to only text type of PDF, and some tools are good with tables. Some tools can do OCR also, but these tools were like very basic tools. If you go with complex data in PDF where we have like unstructured type of information stored, aligned, text aligned with images, snapshots and everything, it's very difficult to get this one. So that's what like this all AI enabled solutions came into picture, and I found Claude API that supports PDF parsing. Like you can give PDF and get the output from that one. It was one of the best tool for any type of PDF parsing, but it's paid one. Okay, now we have Docling that is created by IBM and open source. It is one of the best open source tool available, and most of the time it will work fine for your use cases unless you have very complex type of things. And I found a certain complex thing it could not do it, but most of the time it is 90% time it worked perfectly fine. And most important thing, it is open source. And we have like Amazon Text Track, Azure Doc Intelligence. Basically it is like cloud based services that does a lot of things, like it does handwriting analysis and document analysis. Like it has a lot of other functionality, but further in the if you want to use it in case of RAG, it may not be very useful. We can do very good with these two things. This is paid one. Okay. And we have Llama, Llama 3.2, 11B and 90B, that is vision model. What we can do is we can extract images from the PDF and you store into our system, and then use that images to send it to Llama. That is basically, it may be self-hosted, and it may be like anywhere cloud that is behind like a firewall, VPC and everything. And now we can extract information from that, and you can index it right now, embed and index into vector database. But again, this has limitation. I tried with 3.2 11B because of resource constraint, and it didn't work perfectly fine. But 90B could be very good. And important thing, it is self-hosted. You can do a local type of things if you have resources. Unstructured-IO I did some time back, but I didn't find result good. And most importantly, is like paid one. If you want to go with paid one, it is better to go with this one than going here, because you can deploy this. You can utilize it to some clouds like AWS Bedrock and Azure AI, machine learning, wherever you want to use it. And you can do VPC like virtual private cloud and all this security things set up if you have like confidential or restricted data, instead of going into this place. And based on this, let us see what we can do it in the code part. So let us go to code, and I have all this code available in GitHub. I'm just showing it like what you need to do configuration, and it will be easier for you. I'll not go with the writing code here. I don't want to waste your time. So I have one repo PDF parsing, like one repo. In that I have one folder input, and input I have a sample one PDF that has basically simple like a table in PDF. Like you can see, I can select it, so it is not like a snapshot. Another one is like PDF which has snapshot image data in snapshot. Like I can't select this one, so basically it is image. And another one is like the similar way, some complex table structure. Like if you see here, this is very complex, like it is snapshot but table exists here. And the second one, the similar one we have seen in sample 2. And this sample 4, I mean someone gave me this one. It has like very good things, like it has a lot of information, like layout is very difficult here and there. Parsing is not, like if you try to parse with any other tools like basic tools, it is not able, you will not able to do this one. And you see, like this is one example where we can say like we can find better solution, we can test better solution. I'm not providing any benchmarking here anything, but with this information you can take proper judgment what need to be done. And based on me, my understanding, Claude, Docling was very good as open source. Claude, if you want full proof PDF parsing, that is the good one. So this is input file. Output file I just created like a simple output folder. Some utils I created here. I don't want to go into code. Some PDF to image conversion, like if you send PDF, it will be converted into image. Again, one utils is there, and where that if I send PDF, like 10 page PDF, so it will read as a pair, like in 10 page it will divide by 2, it will become 5 pairs, and 2 PDF will be converted into base 64 encoded. Because most of the tools where we are going to use, not most, like if you are going to use LLM, where we need to pass it as a base 64, because we can secure it and do it like sending it over internet, anything. So this is base 64 content. So we will start with this all part, and it's like very straightforward. I am not putting anything effort into this one, just copy pasting code here and just showing it what it does. Simple. So we will start with creating environment file, dot environment file. So I have Claude API key, I'll add it here. I have OpenAI API key, I'll add it here. Again, this is optional for you. If you don't want to get into this one, if you want to experiment, you can have API key. You need to pay this one and get that. Run your code. If you don't want it, you don't need to run this one. This is optional part. Now I'll create requirement.txt. And in that I'll add all those like libraries required, like dependencies required. So now we have environment and requirement.txt, and now we need to create like a virtual environment in our system so that library doesn't collide with your existing thing. So it is simple thing. Python -m when, and I created .when here, virtual environment. Now it is created here. I can see .when here, and I need to activate in that when we have script activate. So right now we are inside dot virtual environment, like dot virtual dot when, and in that we will do pip installing requirement.txt. So now we can see libraries are installed. So now the next step is Llama. I'm using Llama 3.2 11b as a vision model and 3.18b as a like in RAG as a simple LLM to get the response out of, when we ask question to get the response out of LLM. So I already installed all the requisite models. Like I have Llama 3.1 latest, that is basically 8b, and I have like X Llama 3.2 vision 11b. You can do like ollama pull with the Llama 3.1 latest. You can do simple like ollama pull Llama 3.1, you will install latest 8b. Same if you want to do with the vision, you can go with this like x/Llama 3.2 dash vision 11b, so that it will be available to you. It is basically 11b still take a lot of resources. It takes a lot of time to run in your system. So based on your resources, you can try this one. Now we'll go to the code part, and I'll not write line by line code. I already have code that is in repo, my repo, and I'll use that code to show you what are things needed there. And it's very simple code. If you already worked some part in GenAI, you already know this other stuff. And based on this, like if you go with basic tools, we have this all like LangChain based PDFminer, PDF Plumber, PyMuPDF and other stuff. So we'll start with PDFminer. And in this code I am using LangChain library. You can go to, I'll just provide link of this LangChain documentation, so you can try many other loaders. So since we are not going to use this purpose is not to show this part that people already know. It is just showing it like what are the capabilities there. So I'm using like a simple sample one PDF and try to run this one. So I'm giving it sample one PDF that has like a structure of simple text based table, and just see what it does. It's throwing error. So what happens, sometimes your interpreter is not properly, you can do Control Shift and P and select interpreter. Since we already have .when here like virtual environment, you can select that your virtual environment Python interpreter, so that it will not throw error. Now I'll again run it. So we can see it did parsing, but this is not like the structure. If we go here and see PDF, it has some structure. It's very difficult to find, like it is very difficult to again parse it and get the structure properly out from this particular part. We can do markdown, like say output as a markdown and all those things, but I tried, it didn't work properly. So even you try with different type of even if you go with the different type of files, I'll go with the simple file, this one. This is image based, basically sample2, and it has like data in image. I'll run this one. So there is no output, like it could not find because it doesn't have OCR capability. So that's what I added into my PDF. You can see like what are the capability it has. So it doesn't have OCR, like optical character recognition. It can't find the text over the snapshot, this particular library. And if you run all this library with this type of things, like again I gave it same structure, you can try with different type of file input, you can give your own input and try to run it, you will get the same type of output. So I'm not going into this thing because it is very simplistic way to run this one and find the output. Now I'll go with the Claude part. Maybe before going into Claude, I'll go with the Docling part. That is one of the best library, open source library. So this is Docling based PDF extraction code, and I'm using like Llama 3.18b to do like complete rack type of things, like retrieval also. So it has like I mean, you need to import Docling. It is there in requirements.txt, and I'll quickly go into this part, like main function. Basically it start with your lower, like if name main, and we are initializing because I'm running as a simple file here. And main method, in main method it start with giving input, like I have all this input file path, sample1, sample2, sample3, sample4. So I'm using this like simple sample3 right now. And in this structure content, like get the extract the PDF content. So extract PDF content means I'm just sending it, and document converter. This is basically Docling document converter. If you see here Docling document converter, it is simply getting into this one, and sending file path we get as a markdown output. So this first part is extracting information from the PDF through the Docling library and get the structured content. Now we are using recursive character text splitter using LangChain library. Basically what it does, it takes your content and then it does like chunk by chunk. I'm giving it 2000 chunk, and that's up to you to decide like how much chunk you want to give it to get the coherent response, like to get the group the information in vector database, so that you get the coherent, like proper retrieval from that, like useful retrieval from the vector database. And chunk overlap means like 100, like if we one chunk and the chunk there is 100 words, like it will be 100 character overlap will be there. And when we get that I mean, after running this one in step 2, we get the text chunks and we create vector store. And after that creating vector store, like I'm using fast here, like just to showcase here. I don't want to get into complex any other vector database, like in memory vector store it is basically. So in that Hugging Face embedding, I'm using sentence transformer, all mini lm l12, and then creating with fast vector store. So this third step is basically getting your vector store and then get QA chain. This code is old with the LangChain, like they say it is deprecated, but I found it's one of the good code. I don't know why they deprecated this one and they come with LCL, I mean different complex stuff, but this things works. So what it does, basically we have right now structured content from the PDF. After extracting information from that using Docling, we did text, I mean splitting up the text and created chunks. We stored into vector store, and in that we are running it like QA chain. Basically in that, if you find this one LLM ollama, so I'm using ollama because I already pulled this ollama in my local system. It is available to me, Llama 3.1, giving prompt like, okay, with this information in vector database, retrieve me what I needed based on the question, based on the context what is available in the vector database, and what is the question I'm asking it. And using prompt template and all this QA chain is basically sending all these things, like our LLM, our vector store, and prompt, and get the response. So basically, and this is like not new thing, it is already if whoever worked in GenAI, they already worked on this particular part. So I'm asking question, provide me details of community business base height. So when I am saying this one, community business base height, it is there in sample 3 PDF. If I'll go here and see community business and base height, so I should be getting 35 feet and 60 feet. So that's what retrieval should be, because it is in image, and now we want to see it what is the output with this complex image type of PDF. So when we run this one, it will go step by step. First it will go to Docling, create the structure content, it will do text chunkings, text chunks and then store into vector store, create QA chain with the LangChain related libraries and prompt and everything we are given it. When we are asking provide me details of community business beside, we should be getting answer something related to you can say 35 into 35 feet into 60 feet. That is what base height is there. So it's running right now and it asks GPU. I have GPU, but I don't want to, I want to show it like CPU. If you want to run it in CPU, it will take some time because I'm using Llama 3.18b in my local system with the CPU. Now we can see it extracted information from that image, PDF. But important thing to see here, it could not extract information from this particular image. It is so complex. So it extracted information from this particular image. It has commercial business, CB, office. It looked good. Now Llama model is running to get the answer of particular question what I asked. We get the answer like according to context, we get that base height is between 35 feet and 60 feet. So I see like most of the use cases, we don't go into very complex type of structure. Like this is a bit complex. It's not easy to parse it, but it was able to parse this one. And even I tried with sample 4, and you can run it and just see what output you get it. In that also it was able to parse very good and get that all information. It was able to answer question of that. So this is one like one of the good part in this one, like it Docling, it works 90 to 95% time what is needed. Like other like outliers, we can go with the Claude type of things or image processing, computer vision type of model there. So this is Docling. It's very simple to set up and nothing much into this one. Only thing you need a Docling installed and you need to do document converter. They have many other things into that, like you can go and see their repo, and it has like many examples, custom converter, bash type of things, and many other stuffs are there like full OCR. But I tried this was like default one is try to does like the advanced part. If it try to find everything what is possible with the given PDF, so you can try it here. You can see this repo. I'll give this repo link and you can try it out, all the examples available in this repo. Now I'll go with the Claude and Llama. This is one interesting one, and where that I'm using Claude API to extract information from the PDF and using Llama 3.18b to get that LLM response of the questions in the RAG application. So it is again, I'm not writing code here. I'll just show what is available here. So this Claude and Llama, it uses one utils. If you go there in utils, this particular function, read PDF in pairs, because I'm sending PDF here and it will read in pairs, so that it will not it has capacity of 8192 tokens as a output, like max token. So that's what like I'm giving in pairs so that we can extract information right away and store into index. And all this user library like ollama LM, I'm using it for 81 like Llama 3.18b LLM, and all this recursive character filter and this other stuff for RAG. It is again, we already spoke this one. So I have Anthropic API key, and with this Anthropic API key I'm getting through environment, and we'll start with the bottom part with the main function. We'll go with the step. Again, it has like all this sample 1 PDF, sample 2, sample 3, sample 4. So what we can do with, I'll see with the sample 3, because Docling was not able to run that one. So I'll start with this one. You can try sample 4 and I'll ask. So let us understand like main function. It has like file path what is available here, and one important part from utils, read PDF in pairs. I'm sending it PDF and getting in pairs, like 2 PDF it runs and create list here. Basically, if you go here and just see read PDF, what it does, it has one like a list, and it stores like it runs all the content in PDF, and in 2 pairs it create base 64, it appends and get the list. So for every element of the list, for the 2 page, suppose it has around 7-8 pages, it has like 2 page first one base 64, it runs here for content in this particular list, and extract PDF content. In extract PDF content, I'm just using Anthropic client, where that I need to provide API key what I got from this one, like from the bottom, and in that also providing default header. It is important. So this is basically PDF part is beta part of that Anthropic. They introduced I think last month, and in that if you send PDF, you need to get, if you want to extract information, you need to provide this default headers. So in the client it need to provide. I give some system prompt to extract information from this particular PDF the way I wanted, and model name Claude 3.5 Sonnet, and masses in that all like role, users, content type, document, and base 64 we are sending it, converting, we are encoding it like content of this PDF as a base 64 and sending it, and getting response with the get completion function. Get completion, basically it calls your client of Anthropic and send this model name, and what is max token, it 8192, I think it is the max token it does, and message means like what message we are sending it here. Basically this is the message where we have base 64 encoded string of that particular PDF, and we get the response like extracted information. So this is the simple part. It does structured content, we get it. And I mean, for every run, for 2 to 2, suppose 10 is there in the 5 part, we get that like we are concatenating with that slash and like enter and get the information. Now we again same process, recursive text chunking, vector storing in vector store, doing QA chain and asking question. Okay, it is like the way we did into Docling and Llama. And when we run this one, see the response. So let us run this one and see the response. So now we can see it was able to extract the first content, like a first page of PDF. That was Docling was not able to do that one. And when we see this one, first page, it has like a line, item, code, and everything. So it was able to extract properly first one also, second one also, and the second page of this PDF also, everything. Now with this, like I didn't ask question from that. You can try that one, but I tried once. It worked perfectly fine. Now with this, I'm running Llama 3.1 8B again and get the response. So we can see like according to page 2, this is having 35 bit and 60 bit. So it was able to extract this information. Even I tried with sample 4. You can try it on your own, and you can see like it was able to extract properly, because it has a lot of things that is basically text, not image. But this is very unstructured. This two libraries, like two things, Claude and Docling, is one of the best. If you want to extract any type of information, most of the things you will be able to do this one. Any other things you can experiment. Now the next part is OpenAI, and in OpenAI it doesn't support PDF like extraction. We need to extract the image from the PDF and then send it to model and get the response, like extract the information and do these things like retrieval augmented generation. So what I have like utils, and in utils like I have like PDF to image conversion. When I send PDF, I'll get the image, and in this OpenAI file, like this code, I start with the bottom, and first step is as usual like file path, and PDF to JPG converter. I am using this PDF to image, this one, and in that PDF to JPG converter is one class, so that this part is already imported at the top, PDF to JPG converter through the utils, and using that I'm giving output in the converted image. Like I'm creating one directory here, converted image slash llama, and when we do converter dot convert PDF, like what we got it from there, we send this file path, output path, and get that converted files. Basically we get that JPG files stored into this location, converted underscore images slash llama, and now we use that images, like that directory path, to extract information through the OpenAI model. So when I'll run this one, let us first run, then I'll just show other part of the code. Let us first create one converted images. So we can see converted images here. There's sample 3 page 1, sample 3 page 2. We got this one, and in this directory it goes, runs one by one, get the one image, encode first image content as a base 64, converting into base 64. We can go to this function, see it does simple thing. It does simple thing means like it convert into base 64. Now we'll go down and see other part. After getting this, get completion response from the OpenAI. OpenAI means like OpenAI sending the this base 64 information to OpenAI model and get the response. So I'm using client from the OpenAI basically, and in that I'm sending it, like I'm giving prompt. I need to extract information from this particular image that is in base 64 format to you, and give me the information, structure information out of that, and this all code is for that one only. And when we get the response, that response I'm adding, because it is running one by one, I'm adding it like one by one, and slash and means enter and get that final response. So basically we got final response as a structured content extracted from the images that is generated through PDF, like from PDF converted into images, images in the images in there in directory. Now directory running one by one, creating it like base 64 image, getting response from the OpenAI to extract content from this image, and then running it like simple RAG, all this stuff the way we did, and get the response. Now we see what is this. So again here is I set it like very default. So it forgot to give it 35 to 60 feet, but information is stored properly. You can try with like a different temperature or maybe some better prompt, you'll get the proper response. But still, it's not better than OpenAI, is not better than your Claude and Docling. I found like yeah, still you can try this one. It's again experimentation, you can do it. And now we have Llama Vision. I mean, I don't want to get into this one because it takes a lot of resources of my system. So I'll just go through this one once. Again, this is type of OpenAI only, and we need to get the base 64 content of like a PDF. First you need to convert JPG, like your PDF to JPG, and then using that JPG to get that response from the model. Like again it was same as OpenAI, converted PDF into files. It goes into this place, maybe other place you want to run it, and again getting response from the extract image content, like one by one just see it and get the response, and then getting it like through Llama 3.2 11b vision model. It is just like extracting. Earlier we did with OpenAI. Here we are just sending it like a image, base 64 content of that particular image, because it's there in directory. I'm running in directory one by one, getting base 64, sending it into like the way it is supposed to be there in Ollama chat. I'm using ollama.chat here, sending it like model messages, image base 64. Basically content is basically your prompt that is supposed to be there, and get the response one by one, and store it into like again if you're running one by one, add it to plus new line and get the final response. When you get the final response, your task is again this is the part you need to struggle. After that, this is the simple part. Like it is just giving example, it is not like extraction part, is more of your RAG part. So I'm not running this one. You can try it if you're good enough resources. So likewise we have Camelot, and we have like Amazon text extract. I don't want to get into Amazon text extract. Maybe I can give it in another video where you can configure like Amazon configuration. It will be too much complex, and if I summarize everything, I found Docling is one of the best open source libraries to do most of your task PDF complex, like complex PDF extraction. If you have more complex things and already using Claude, you can use it. Claude, it is one of the best, like best of the, I can say it is it works in most of the scenario. So you can do set up everything whatever you wanted to do it in your like virtual private cloud, and security and other stuff, whatever GDPR and other security requirement. But this all part are good when you have like your PDF is only text. You don't want to get into this one to do these things. Even you can use Docling, that is fine, but make sure just go through all the libraries inside Docling. If it is using any internet resources or anything that is not advisable, to go, your data should not go into some other place, because it uses internally some models. It extract information from some other places, internet. I did check, I didn't find much, but I'll explore more in case if it uses anything internet, sending any information to internet.